Hello everyone and welcome back to another YouTube video. My name is John Hammond, and in this video we're going to start to take a look at some of the HackTheBox University Capture the Flag, or the CTF, that was running this past weekend. Get a look at some of the challenges, try our hand, and see how we do. So before we dive in, I do want to give some special love to HackTheBox. They were kind enough to let me kind of get a chance to play around, get a chance to explore, get a chance to look at some of the Capture the Flag challenges, despite myself no longer being in university. So thanks, guys. I super appreciate it. Forgive me, those of you watching. I am going to be in sort of a sandbox environment dedicated for myself, so this is JHCTF. But hey, I super appreciate it, and let's get the ball rolling. I'm first going to start off with this challenge called Strike Back. It is in the forensics category, and I think this is kind of a fun one to showcase. Let's take a look at the challenge information and the description here. It says, a fleet of steam blimps waits the final signal from their commander in order to attack Gogglestown Kingdom. Okay. A recent cyber attack had us thinking, if the enemy managed to discover our plans and prepare a counterattack, will the fleet get ambushed? So not extremely helpful for what we're going to be doing in the challenge, not a whole lot of context, but we can go ahead and download this file here. I'll get that started, and I'll go ahead and fire up a command line. I'm hitting Control-Alt-T just to open a command prompt here in Ubuntu, and I have a Z shell set up. You can tell by the pure prompt with like the syntax highlighting for commands that I run, and we'll go ahead and make a directory here for I guess YT UniCTF or YouTube UniCTF, and let's make a directory for forensics. Hop in there, make a directory, if I could type, for Strike Back. Good enough. Let's hop in there, and let's move from the downloads folder that forensic strike back zip into this current location. We have it in this directory here. I'm using exa as a replacement for the ls command. Just have it aliased here. And we can go ahead and unzip this, and we have some files here. Okay, inside the folder that's created a freesteam.dmp or dump and a capture.pcap. So some packet captures that we might be able to take a look at. Let's move into that directory. And let's see what we're up against. I'm just going to run file on all of these files here. And of course, PCAP is a PCAP, as thankfully we were expected by the file extension. And this dump is a mini dump crash report. Interesting enough. So truthfully, you could do kind of whatever other file reconnaissance you might like. PCAP we could obviously open up within Wireshark. Freesteam.dmp. I'm not exactly sure what to do with this .dump or .dmp file extension. So I, again, being a skitty, being a scrub, I just kind of ran strings. And I'll pipe that to less so you can kind of paginate the output here. And there's some interesting stuff that comes through here. We can see some NTDLL PDB files, which I believe are debugging symbols for a lot of well-known or at least common DLLs that you would see in the Windows world, not strictly in Linux. So I'll scroll down through here, and this looks to be plentiful. But there wasn't immediately anything to showcase, except, hey, this program cannot be run in DOS mode. Maybe there's an executable kind of embedded somewhere in there, normal strings that you would expect from just a flat exe or DLL or a PE file, right? A portable executable that you would find on Windows. Not a ton of good stuff to showcase there, so let me speed run through most of this. However, we start to see some interesting errors and strings as I'm scrolling through this. And again, this could very well be optional, right? You might not end up cruising through strings if you wanted to crack open Wireshark and do any of the good stuff there. But eventually, as I scrolled through this, I saw the exe file, and then later down, after seeing all of these error messages and I guess format string specifiers, some specific privileges that might be present on Windows for things that it could do. But I also started to see some really, really wacky stuff. I started to see some IEX or invoke expression PowerShell aliases, just the very, very same with some PowerShell commands running with no profile, bypassing the execution policy, and supposedly downloading files from a given location, really on localhost though. 127.0.0.1 is that loopback address. But I see HTTP streams, some cryptographic providers, I totally said that wrong, and lots of other potential Win32 API functions and calls here. Later down, I thought I saw some weirdness, again scrolling through a lot of these shenanigans. I'll get to the point here eventually, I promise. This is the danger of kind of using strings as an I believe button, right? But there is a lot here. Actually, you might be able to see, yeah, a weird looking username, npatrick, and a home directory, or at least a user profile, downloading this file freesteam.exe, which is not our freesteam.dmp or dump file. So there's some oddities there. We might be able to do a little bit more understanding as to what this file really is. But again, there is a smoking gun that I want to showcase, and I promise I'll get to you eventually, even with the extremely baby cakes cursory understanding with strings. But you can see, hey, we're enumerating what looks like system variables or environment variables on a Windows operating system. Blah, blah, blah. Some of this, as it's flying by, might be a little bit more interesting to you. And maybe you already have an inclination as to what the heck this thing is. I promise we'll get into it, but I do want to showcase this breadcrumb that I found that lead me to a quick and easy win. You'll notice back on the HackTheBox interface, okay, here it is. It looks like it's over here. Just barely at the end. You'll notice on the HackTheBox interface, this was denoted as a medium challenge, or 2 stars worth of difficulty. So let me tell you about the speed run that completely removes that. Some of these text entries you might see here, end stream, end object, type font, etc. Some of you might recognize this like, oh, that looks like the structure for a PDF file, like you might typically see. And a lot of these kind of the notation of the forward slashes, capital words, and greater than and less than symbols. I started to think, is there a PDF file in that? So I ran, of course, any other file carving utility you might use, like binwalk or foremost, and I would run foremost on this simple freesteam.dmp, and it will go ahead and output an output directory. That will have carved out some of the interesting files. Looks like it was a DLL potentially and a PDF. So let's go explore that PDF. Looks like it has this file name, right? Carved out at whatever file position this was, or byte position that was in the file. And I'll use Evans just to go ahead and open that up in a PDF browser and viewer. And this is a allegedly confidential document, right, for the 12th blimp fleet do not share. But quick and easy without doing anything else really for the challenge, we found a flag here that we could go ahead and submit. Now, I have to think this is not the intent of the challenge. So if you were listening for, hey, the quick and easy win to get a flag, there you go. Cool. You got the gold. You got the glory. Submit that for whatever points or learning value. But you might be wondering, what the heck? We didn't even look at that PCAP file. And you're exactly right. So let's fire that up in Wireshark and kind of take a closer look at this. If you aren't familiar with Wireshark, for whatever reason, it is a packet capture analysis tool, right? So we could be able to really get a better look at all the stuff going on here in this network traffic, right? We see a download for freesteam.exe. And this is a lot of HTTP traffic and TCP traffic, right? A lot of this green that you might be able to see on the right-hand side is a good color indicator. Hey, we're working with HTTP and TCP traffic subsequently. But you'll see some GET requests and POST requests with interesting ID values, but it's communicating between some local IP addresses. 192.168 local IP address, 1.7 talking to a 1.9, and this is just it. Like, I've been scrolling through this, but it is just this repeated HTTP traffic. I could look through a couple of these HTTP streams, and you'll see, hey, here's the client and server response, posting data or getting data back and forth. And honestly, this all comes from the stream or freesteam.exe that we may very well have found. But the endpoint and the URL that you see for these GET and POST requests, like a CX, and there are a couple others here. You could very well run something like TCP flow if you'd like. TCP flow TAC R, on that capture.pcap, and that will churn out a boatload of files, really whatever potential things it might be able to find. And again, if we ran file on all of these, I'll zoom out so that's a little bit more readable. A lot of these are just simple text because it is the data maybe going back and forth between HTTP headers, right? If I try and cat that out, hey, you can see there's the GET request for the simple HTTP response. We could do that with a couple others, but of course the binary data in each of these is really what's interesting. So that leads us to wonder, what the heck was that DLL that we saw inside of the dump file, and what really was this dump file to begin with? So let me, did I even LS that earlier? Oh yeah, these are just kind of like empty boilerplate response headers. Nothing interesting. So let's go again, take a look at that DLL for a moment. And we have two DLLs, right? We saw other potential files in there. These are just straight compiled DLLs, though. It's not a C#.NET assembly or anything that we might be able to crack open easy peasy in ILSpy or DNSpy or .peek or whatever tool may have you. So again, let me resort to my script kiddie ways and just kind of ask the internet what the heck this thing might be. I have a sneaking suspicion it might be something spooky and shady and malicious. Let's upload that dump file to VirusTotal and see if it is anything potentially malicious or if it just tracks down and finds anything more in between it. We could very well upload our DLL files just as well, but it looks like, hey, we have a couple antivirus engines not finding a ton on these. Like, okay. A couple engines are saying this is COBALT Strike, and it suddenly went away. Okay. Just a few, though. Alyak, Sangfor Engine 0, and eScan. But this is, again, just the dump file. It is not the malicious, potentially malicious DLLs that we would have found. Can I go back here, guys? Okay. Let's choose a file yet again. We'll go into the output directory now, and let's supply one or two of these DLLs. However, they look identical in file size. I'm in that directory. Let's do a SHA-256 on both of these. Okay, they are different. So I just want to do a little integrity check the hash value. They are different, but the same file size. Interesting. Or close enough for the same file size, interestingly enough. Ooh, so this is going to start to light up, apparently. A decent amount of these are coming back. Hey, injection, COBALT Strike, hack tool, Meterpreter, COBALT Strike. COBALT Strike seems to be the overwhelming response. XOR encoded. Nice. Lots of red. Lots of blood and carnage on the screen, right? But mainly, it looks like COBALT Strike is the top contender here, which is cool. We haven't dug into a whole lot of COBALT Strike kind of on my channel or showcased much with this, but this has been analyzing for a while. We can kick it to the other one if we'd like. This looks like it has a hefty number of detections here. Regardless, I guess we could do a little bit of research as to, okay, what the heck can we do with a COBALT Strike beacon? I'm going to assume that this is, right? The freesteam.exe or the freesteam.dll or whatever. Did this believe it was back when we ran file? Oh, no. It still does say this is a DLL. But yeah, boom, 49 out of 64. Good numbers up in here. Let's kick the second one, even though we kind of know what we're going to end up seeing. Whatever. While that's kicking around, we can do some research, right? COBALT Strike, beacon, forensics, network traffic, I suppose. Just simply Googling and analyzing a malware PCAP with iced ID in COBALT Strike traffic. I'm going to use my classic technique of click on literally everything. So dark reading might just be a news thing. Yeah, how to identify COBALT Strike on your network. That might not have the best runway for us, but we can explore. So Brad Duncan on a malware traffic analysis showcases some of this cool stuff. Ooh, some of the PowerShell downloading. Oh, and they're using a run DLL32 payload, I'd have to think. Okay. File headers coming down. This is going to end up being iced ID, though. This is going to be a different malware family, not strictly COBALT Strike yet. So just from cursory glance, I don't know if that's going to be... Oh, they do offer a COBALT Strike beacon download, which we can decode with Didier Stevens. Fantastic Python script. Ooh. Can I play with that, maybe? Yeah? Are there any other tools Are there any other script kiddie things I can latch onto? Here it is. Yeah. Didier Stevens, fantastic fella, puts out incredible work. This tool decodes and dumps the configuration of COBALT Strike beacons. Let's try it. It just gives me a zip file to download. Whatever. Beggars can't be choosers here. Is that going to download? Hello? Okay, HTTPS came through. Let's move that download 1768 to go ahead and unzip this here and work with it. And we have a Python script. I'm going to assume, being a Python script, it is a Python script. Wow, incredible. Okay, I don't see any notion of whether or not this is Python 2 or Python 3 yet. Let's just try it. Can I just kick it the file? It uses opt parse. Oh, it does determine whether or not it's going to be using Python 3 or not. Nice. There's a lot of documentation and shenanigans in here. Okay. I have obligatorily read and scrolled through the script, so I'm not just downloading a random thing from the internet and running a random thing that I downloaded from the internet. But what do you do? Anything? Or are you just waiting on input? Is there a help? Oh, yeah. Perfect. Source code, put in public domain. Use at your own risk. Yep. Analyze COBALT Strike beacons. Okay. Can I use this on any of my DLLs? Let's go for the 444 one. Whoa. That got some things. Hey, yeah, it actually found some configuration details, right? Spawn to x86, spawn to 64. Public key, nice. Malleable C2 instructions. At this point, this is just exploratory. Forgive me. Whoa, but payload type Windows beacon, HTTP reverse HTTP. With a port, max get size jitter. It's literally carved out. Hey, the config file information. Yeah, and there it's going to 192.168.1.9/CX. Very cool. Post URI to submit PHP, just as we saw. That's neato bonito, man. I'm assuming it's going to do the very, very same for our other DLL, which is the 823681. Oh, didn't actually track down anything. So maybe that first one is kind of what we're looking for there. That was fun and neat, but how would that make us get anywhere closer to naturally finding the flag? Security Boulevard showcases some of this, allegedly. Okay, they're showcasing Hansitter. Oh, and this another malware traffic analysis lab. Cool. Oh, hey, and they're using the exact same Didier's tool. What is COBALT Strike from Help Systems? Hey, the real actual documentation from COBALT Strike. And I should have done a better job explaining what COBALT Strike is if folks don't know. It is a adversarial emulation and post-exploitation framework, right? So used by red teamers, used by penetration testers, used by people trying to better security for organizations and companies and businesses that want that. However, right? You know the cheesy saying, with great power comes great responsibility? Turns out, if threat actors and adversaries and bad guys get their hands on a cracked COBALT Strike install, they can do some damage. And even a script kiddie like me could make it happen. So, this is dark reading. Yeah, I'm gonna put a pass on that one. Sorry. The Enviso Labs, though. Hey. Using known private keys to decrypt traffic part 2. Is there a part 1? Oh, yeah. If we haven't already, we invite you to read the first part of this. COBALT Strike using known private keys to decrypt traffic. Ooh, we have encrypted traffic. The communication between a COBALT Strike beacon or client and a COBALT Strike team server, C2, the command and control framework, is encrypted with AES, even when it takes place over HTTPS. The AES key... I don't know why that was weird to me. Encrypted even when it's over encrypted traffic. Wow. The AES key is generated by the beacon and communicated to C2 using an encrypted metadata blob, a cookie, kind of like we saw in that 1768 Didier Stevens script. Slick. Public and private keys are stored in the .cobalt strike beacon keys. Keys are generated when the team server software is used for the first time. Okay, so we can assume that has already been put together, but it is the beacon that keeps track of the key, right? So because we have this beacon, the DLL file originally, the key information is now included in that tool. Excellent. Did ours have that output? We had a private key, right? Or we had a public key here. This fella, all this hex data here. Whenever a public key is extracted with a known private key, the tool will highlight this. Well, we don't have that output. We do not have the has known private key emphasis in our case. So we have some other work to do. At a minimum, this information is further confirmation that the sample came from a rogue COBALT strike server and not a red team server. Using option verbose, the private key is option displayed. Wait, can I make that verbose? I should have done a better look at the help arguments here. No extraction. Oh, I want you to extract things, I guess. I don't know. Password, verbose. Is there a TAC V? Oh, no. That's just version. What am I not seeing? TAC capital V? They're using TAC capital V in that screenshot. Nope. Doesn't know what it's doing in that one. Part of me wonders if there is a updated version of this. No, they link it to the same blog post. Unless, this is 2020. Ooh, I had an old version. That's why you gotta check. Yeah. Okay, updated Monday, October 11th of this year. I'm digging that. Give me that one, please. Apparently only need HTTPS. So, yeah, I had the old version. This is why we learn on the fly, folks. And let's kill the old script, too. Let's move that download 1768 in here. And let's unzip that, please. Cool. Now we have a JSON script file and a script. So I'm assuming kind of exact the same thing. I forgot the .py extension. But yeah, this looks normal and a better update date. So how about you? Still only reads from standard input, but if I supply tag H, there is now a verbose output. And this updated copy might just straight up tell me, hey, we potentially know a private key for you here. So let's see if we get the same results. Oh, and there's even a little, were there a little bit more configuration things that it was able to pull out? Looks like it. Digging through this. No, still does not display a private key. Even with TAC V. Nope, just gets the public key. Okay, let's keep reading. Let's go back to that article. Whenever a public key is extracted with a known private key, the tool will highlight this, as we have read. This can then be used to decrypt the metadata in the C2 traffic. More on this later. Wait. Can I... But what if I don't have a private key? Am I Dumbo? Config found XOR key. Oh, just a period byte. Am I missing some piece of the puzzle that would like significantly make this easier? Maybe not. Does the second post explain this? An upcoming blog post will detail how to do this. I was just in part 2, and they're showcasing the same example from malware traffic analysis. But we open the capture file with Wireshark, which we have. And we look for downloads of a full beacon by stage or shellcode, which I think we had, right? Because we were getting a specific page and returning a DOS, or a whole executable. We have one hit. The path used in the GET request to download the full beacon consists of 4 characters. Ooh, what is this meta tool? What is that? Oh, more Didier Stevens. Great work, fella. Metatool is a tool to help with the analysis of Metasploit or COBALT strike URLs. Nice. Still in my GitHub repository. Let's check this out. Also add some COBALT strike stuff. Okay. Let me continue onward, because I still don't exactly know what to do if we don't have a private key. Is there any other options that we could do for decryption? No. They showcase it. That one still also has a Hasman private key. Learning on the fly, ladies and gentlemen. I'm super sorry if you're bored to tears. Blah, blah, blah. Whoa. You could CS decrypt metadata. That would be super handy. Am I speed running through this a little bit faster than I should be? Wait. The private key is not the only way to decrypt the traffic. If the AES key can be extracted from process memory, we can also decrypt traffic. We'll cover this in an upcoming blog post. Wait. Oh, this is Didier's post. Excellent. Is there another one? Ooh, yeah. COBALT strike using process memory to decrypt traffic, part 3. Let's do it. We decrypt COBALT strike traffic with cryptographic keys extracted from process memory. That's why we have a .dump file. The memory. I'm an idiot. I am a... This series of blog posts describes, yes, everything that we've already read. Part 2, we obtain these keys by decrypting the metadata with a private RSA key. Another way to obtain the AES and HMAC keys is to extract them from the process memory of an active beacon, which is what we were doing. One method to produce a process memory dump is to use SysMon's proc dump. No, we already have it. For COBALT Strike version 3 beacons, the unencrypted metadata can often be found in memory by searching for a byte sequence beef. Nice. This sequence is the header of the unencrypted metadata. Can I find that? Like I could look for it in hex, like on my own, I guess. Hex edit 0004, and then just look for beef. Does it find it? Is that right? Is that? Now I don't trust myself, because that is surrounded by zeros in their example, and not. I don't think that's it. Let me check the tool. Let me check the thing that is clearly smarter than me. Here they showcase this: extract cryptographic keys from COBALT strike beacon process dumps. Yeah. Let's swipe this real quick. Forgive me. Let me out. Let me out. I want to leave this program. Hello? Q? Quit? Okay. CS extract. That's called extract key, right? Yep. Extract key.py. Slap that bad boy in there. I should throw this in opt, because I know that I will want this more. And how does this look? Does this also read from standard input? Totally. Attack H will do some good stuff. Extract cryptographic keys from COBALT strike beacon process dump. Oh, I should have actually been looking for that in the memory dump, in the dump file. So maybe I had it wrong all along. Here, let's go ahead and move the output DLL CS thing into my opt directory, and then let's go ahead and Python 3 from the opt that on our freesteam.dump. Yes. Does that need other arguments? How do they showcase it? No. It just does it. What? Am I doing that wrong? Does it need to be Python 2? No. Okay, so it should have been fine. Python 3 has that installed. Does it genuinely need to be in the DLL that we had? That wouldn't make much sense to me. Output DLL 0004. You know what you're doing, supposedly. I should probably read the instructions. Options at file. Oh, does it need to know if it is an at sign or not? Does it need like a special representation if it's reading from a file? No, because it knew that already. Full search. Tack F. Do I need to look through the entire thing? Maybe I should have looked in free Steam memory dump to begin with, and maybe I should look for that beef again. There is beef. Is there more beef? There's a lot of other beefs, but that just could be maybe a hitch. I don't know. What else can we do? Are there other options? Oh, metadata contains the raw key. The keys can be used to decrypt the captured network traffic with CS parse HTTP traffic. So I genuinely need to look for 0000 beef. How about that? That is not found. Okay, so that won't work. Maybe this isn't a Cobalt Strike 3 beacon then. For Cobalt Strike 4 version beacons, it's very rare that the unencrypted metadata can be recovered from process memory. Oh, okay. For these beacons, another method can be followed. The AES and HMAC keys can be found in the writable process memory, but there's no header that clearly identifies these keys. They're just 16-byte long sequences without any distinguishable features. To extract these keys, the method consists of performing a kind of dictionary attack. All possible 16-byte long non-null sequences found in the process memory will be used to try and decrypt, oh my goodness, to try and decrypt some of the encrypted comps. If decryption succeeds, then a valid key has been found. Okay, that sounds like good brute forcing. This method does require a process memory dump and encrypted data, which we have. The encrypted data can be extracted using CS parse HTTP traffic.py like this. You just tack K with a key unknown and then the traffic. Okay, so let's yoink this guy and do the very, very same. We'll do a subl opt CS parse HTTP traffic. This is probably only in the case if it is not HTTPS, right? Because then you wouldn't be able to particularly know what the traffic is because it's already going to be encrypted over HTTPS. So K unknown. Oh my gosh. I still got it wrong. K unknown and free steam.dump. You need Wireshark. Okay. Let's go ahead and install that with pip. My boy Pip. Please. Oh, this virtual machine has that shenanigans where it needs to like have IPv6 turned off. Stand by, please. Okay, I have this syntax just straight up saved because I literally always forget this. And for some reason, my VM does stupid stuff. So hopefully that'll actually start and get faster. Good. Thank you. Let me close that Obsidian window in the background now. Wireshark is now installed. Now let's do... T-Shark's not found. Yeah. Oh, gosh. Install T-Shark, my dude. How about that? How about them apples? All right. Now we're cooking with Why? What did I do wrong now? No. Unknown capture.png. It'll encrypt the packet like this. It didn't do it. Am I? Oh my God. I feel like I need to edit that part out. I should have run it on the capture pack. I'm sorry, guys. It's past midnight. All right, now we got a lot of stuff. So much so that my camera decided to turn off. This is so much stuff. Let me output this to another file. Let's redirect that to like output.log. Out. In the outhouse. Oh gosh, this is the folder, output.log, tons of stuff. All right, cool. So packet 103 is an HTTP response to a GET request. The encrypted data of this response is 64 bytes long. Is that what we're looking for? We're looking for a 64 byte one. This is encrypted data sent by the team server to the beacon. It contains tasks to be executed by the beacon. We can attempt to decrypt this data by providing tool CS extract key with the encrypted task option tag T and the process memory dump. Do I just arbitrarily choose one of those encrypted pieces? Or I guess any of them, right? And yeah. That sounds right. It looks like his tool will be able to do this already for us with the extract key.py. So we need extract key.py, tag T, some traffic, and the dump file. Let's find one that is 64 bytes long, if there are actually. So we'll use regular expressions. Let's look for A through F and 0 through 9, and let's look for 16 bytes, and then a new line, I suppose. And starting on a line, 64 bytes, sorry. None of those. Do I have any short lines? Or all of these ginormous? They're all ginormous. Maybe we can just do it until my terminal yells at me, I guess. Let's try it. How about let's look for all of the length ones. So that's a humongous... Oh, camera. What are you doing, dude? Oh, here's a good one. 48, 76. Those look much better. 80. But we want it off of a GET request, don't we? Let's use a 66. Let's use this one. Let's experiment and try that. So Python 3 opt CS extract keys with tag T being encrypted task, and then a dump file just being passed as another argument. So that would be our freesteam.dump. Searching for AES and HMAC keys, searching after given string. So, ooh, found one. I think, right? Searching for raw key. Is that the output that I'm supposed to have here? Yeah. Allegedly. I mean, yeah, we have the HMAC key and the AES key, do we not? Yeah. Yeah. And it's been validated, supposedly, for a second time. So then we can decrypt traffic with CS, parse HTTP traffic, and then the HMAC key and AES key. So let's get the HMAC key first. Opt CS, what was it? It was parse HTTP traffic, and now it's tag K with HMAC. And I will clear my screen in just a moment. Forgive me. Like this. And that is the correct syntax, correct? Yep, and the capture.pcap file. So let's see if that does it. Ooh. Ooh, it did it. Okay. There's stuff in here. Let's redirect that to a final dot log, I suppose. How about that? What? Okay. Packet numbers and post requests that we're seeing. We're seeing get UIDs from beacon tasks. Oh, and we actually can tell, hey, what user this is. Whoa, we can see the pipes and the commands being used. This is actually super duper cool. Oh, the output from that command. Dumping password hashes. Oh, that's so cool. Holy cow. I got to be honest, guys. I haven't done this before, so if it wasn't obvious. So much for my credibility, dude. It's out the window. But we're learning together. A lot of these. And this is this is Mimikatz, LSAS, dumping, shenanigans, stuff. Oh, file downloads? Wait a second. This is where we would have tracked down the PDF file and an Excel file and some of those secret documents. Can I save some of those? Download start orders. There was something to be able to extract stuff out, right? Wasn't there? When we were looking at this earlier in the help, no, that's just for extracting things. Transform, T-Shark display. Oh, no, extract payloads to disk. Extract payloads to disk or extract like downloads? That's TAC E. So does that work? Payloads. Are each of the are those payloads? Oh goodness, sorry. Let's do that on thanks for that insane autocomplete, Z-Shell. We can tell nice that we have the executable files, the payloads themselves, and a PDF document, right? Executable here. So if I were to actually move this to a sane.pdf file, that is a PDF file, right? So let's open that. And, oh, sorry, I used Eye of Gnome EOG to try and open an image. It should have been Evans to display that out. And that's it. Wow, only took us 40 minutes. Oh, that's so cool, though. Like, that's literally carving through some COBALT strike shenanigans and not my stupid baby cakes run foremost. But honestly, like, you literally could have solved that with Katana. Like, the stupid, like, auto CTF ripper that Caleb and I had experimented with some time ago. Like, this you would have just found in the PDF text or some image or something somehow of the PDF that it would have carved out from this. But that journey that we just went on together was significantly more fun, and had a lot of good insight on some COBALT strike stuff and how all this encryption is done between the beacon and the command and control server. So I am very, very pleased that we went through this long and winding road together and found some pretty great tools. I mean, Didier Stevens putting out incredible stuff. I love it. Yeah, man, totally. I'm also always extremely worried if I'm saying his name correctly. So, my friend, if you're watching this, don't hesitate to leave a comment and be like, "You idiot, John." But wow, hey, that was a ton of fun. After all of these many tabs we have open, we could totally go ahead and submit the flag if I hadn't done that already. So that's it. That is the Strike Back Challenge from the HackTheBox University CTF. Really, I'm pleased with that. I know that might have been a medium. We might have knocked it down to an easy using foremost and strings, but wow. Look at all the lessons learned on that. We had a great flag to uncover and really cool stuff. So kudos to you guys, as always, for putting on some super cool CTF and some great challenges. I'm super excited to be able to share more with you guys. So hopefully this will be the very first one in a series of other videos that I'll be able to get done showcasing the CTF and all the other great things that it has to offer. But let's see how we do. It's 1 in the morning, guys. Let's see how many we can crank out. Thanks so much for watching, everybody. I love you. I hope you enjoyed this video. If you did, please do those YouTube algorithm things. You know I would love if you could like the video, subscribe, comment, all those things. If you have any interest in supporting or helping this channel grow, helping me, helping support, there is Patreon and PayPal. If you're, again, offering some generous donations, it incredibly helps, and it makes me be able to make more for you. So thanks so much for bearing with me in this crazy long video, everybody. I love you for real, and I'll see you in the next one. Take care.